Lesson 4, day 2 is also expected for you to do. And as a reminder, you needed to make sure that in the previous day you had completed the success criteria. Give yourself a score. How could you improve? You also answered the exit ticket, and then the problem set, it was homework. This is the problem set for lesson 4, day 1. Make sure you get that done. We move on to lesson 4, day 2. There are 3 dot plot questions. 2 of them are in the entry tasks. And I'm going to go ahead and skip these 2 and say you need to do these after I have done the example on the next page. Let's go to data set 3, the next page. Data set for age of cars. 25 car owners were asked the age of their car in years, and the results are recorded below. So we're going to turn this, even though it's not there and it should be, create a dot plot. Why else would there be a number line? The purpose of the dot plot is to kind of help us see the balance or the skew versus symmetric shape of the distribution. So do your best to, as you add a dot or add multiple dots, that you keep a sort of evenness to the way that you elevate the numbers that you're given. So every time I come across a new number, I'm going to make a new dot above that value on the scale. That way 2's are about the same height. 6, there are 3 sixes. Spooky. Then we want to make sure that we go up 3 spaces. There's 1, 2, 4, 5, 6, 7s. So 1, 2, 3, 4, 5, 6. There's 1, 2, 4, 5, 6, 7, 8, 8. 2, 3, 4, 5, 6, 7, 8. Whether we do this perfectly or not, I hope you did. Still can it out. You can see that there's a symmetric shape. This is totally like, not in the middle. This point. It should be in the middle in order to say that it was symmetric and it's not. So our distribution is skewed. Now the question is skewed to the right or skewed to the left. A lot of the numbers are 7 and 8, and then only a few are over here with 0s, 0s, and 1s. So you can imagine that there is a pulling from the collection of numbers around 7 and 8 to the left side. Once answered this question on previous homework, I said it was skewed right, and I have to correct you. Not. This is a skewed left distribution because most of the number here at 7 and 8. It's like wad of data pulling to ones, and which way are we pulling it? That way. If you calculate the mean, head into a website and get the answer. So I just typed standard deviation calculator in Drive. Typed all of these numbers in commas and separate. And I got bar because that's mean of 5.888. Like there is x bar. And then calculate the median. So the median is a little easier to see because of the arrangement of the table. Cross. Oh, there's your median. The other way I could is that there's 25 cars, so I know that there's going to be at least 12 below the median and 12 above. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are all above, and these numbers are all below the median. So since this picture is skewed to the left, and median is right here, and let's look at it. There's 6 plus 8. There's 15 that are at 7. 13 out of all 25 are at 7, and only 3 and 1. So I guess that's typical number is 7. This is typical because look, the numbers are right here, and saying the mean of 5.88. This is not typical. It's not typical because it's over here on there's 1, 2, 3, 4, 5, 6, 7, 8 and 8 numbers. Only 8 numbers are smaller than the mean, and 17 numbers are bigger than the mean. So it's not really the middle. So that's the other part, not in the middle. Typical would be it's like or near the most of the numbers. Median totally does that. So if I can make an equation then, if skewed, don't do mean, do median. Right? Question 3, I think, is a throwback to the entry task question. I recommend. Oh, in fact, I did this wrong myself. So I'm doing the work for 25 car owners. Forgive me. You're probably following along, doing what I did, and you're doing an amazing work because you know, just copying along. All of these work right here, as I realize now, sheepish chuckle, LeBrant. They go with right here and right here. Surprise! Surprise! Let's do 5. You know what? I wrote these down. If I can say arrows, go there and go there with them. And sorry, sucks to be you. Get it done. Describe the distribution of the age of cars. The distribution of the age of cars is skewed left with word mean, because the mean is wrong. By the way, I got a standard deviation of 2.37 using that website, with median of 7 and oh, I forgot my IQ. Okay, IQR would be, of these 12 numbers, what's the number in the middle of these 12? So 6 below, 6 above. 1, 2, 3, 4, 5, 6. Oh, it's just 8. So Q3 equals 8, and then in the 6 below, 6 above, so 1, 2, 3, 4, 6, 6. 1, 2, 3, 5, 6. Okay, halfway between 4 and 5, 4 and a half. So if I take those two numbers and subtract them, I get an IQ. Real on the page. I get an IR of 3.5. Are there any outliers? Do the outlier fence. But going from 0 to 8, there are no outliers. This right here, if I just add this to 12, I get a number nearly are no outliers. Okay, yes. I'm sorry. Get over it. But you should practice determining the mean and median and making a choice, which makes a more typical number, a number that's in the typical means in or near the most. And while my results here are actually supposed to go 6 and 7 and with 5, you should go back and practice 2 and 3 for dot plots in the entry task. After you're done, that's the whole point of the lesson. Is go back and rate yourself for the learning targets criteria. That you should also do the etiquette. Oh hey, let's fill this one. Mean versus mean. Why would we do one over the other? The mean and the median of the distribution are numerical summaries of the center distribution. When the distribution is nearly symmetric, the median of the distribution are approximately equal. When the distribution is skewed, the mean and the median are not the same. Not even they're close, but they're really not close. When the data is this was a question. Look back here at this dot. I'm gonna leave the blank. The data is blank. It could be right. When the data is blank skewed, the mean will be in the median. When the data blank skewed, then will be smaller than the median. And in order to get an idea of what that is, I'm back at the dot plot for the car owners. Here it's a left distribution, and look at how the mean is on the left of the median. Hey, like they rhyme. It's like that skewness is pulling average in its direction. So when the data is skewed to the right, the mean larger. It'll be higher numbers. When the data is skewed left, the mean smaller. That's what we see here. The mean is smaller than the median, and so we know that right and left are things that need to go there. For symmetrical distributions, the mean is an appropriate choice for describing a typical value for the distribution. For skewed data distributions, the median is better. Okay, that completes that final box. Know that you need to do the exit. Probably going to be like a quiz question. Probably something we should talk about. And you should also do the problem set for day 2. Yes, all of it. Hint, that's a symmetric picture, so therefore it should be using mean.